All right, today we're going to be learning about graphing logarithms, but before we can graph logarithmic functions, we need to talk about what log means. So let's say we had these equations here. 2 to the x power equals 4. Well, we know that 2 squared equals 4, so we would know that x equals 2. And here, 2 to the x equals 8. We know 2 to the third is 8, so x would equal 3. What about if we had 2 to the x power equals 6? 6 isn't a perfect power of 2, but there is a way that we could find the exponent, and it's called logs. So log, we're going to write out how to say this, log base b of y is equal to x. If and only if b to the x power equals y. Now, there's two logarithms that have buttons on their calculator, on our calculators. It's log base 10, which is the log button on your calculator. It's next to the 7, or right below the 7. And then log base E, which is Euler's number, we'll talk about that more in a later lesson, it looks like ln, it stands for natural log of x. That's also a button on your calculator. So let's look at how these are related. If we look back, our base went from a subscript to being a whole number. So if we wanted to rewrite log base 4, the base 4 is going to go from being a subscript to being a whole number. The y that was after the log became what it was equal to. So here that's 64. That's going to be what this is equal to. And what the log was equal to became the exponent. So what it's equal to becomes the exponent. And is 4 to the third equal to 64? Yes, it is. So in number 2, 5 is our base, 3 is our exponent, and it's equal to 125, which is also a true statement. Number 3, 7 is our base, 0 is our exponent, and it's equal to 1. And 7 to the 0 power equals 1. So let's do the opposite. Let's go from exponential form to log form. We're going to have log. Our base was 3, so that becomes our subscript. Our exponent is what it's equal to, and what was equal to becomes what we're taking the log of. So number 5, log, our base is 2. Make sure your bases, they're subscripts, so they should be small and down where the tail of the G is. Of 32, that's normal sized, is equal to 5, which is also normal size. And then finally, log base 4 of 64 is equal to 3. Now, what does log base 4 of 256 actually mean? What is it asking us for? What this is asking us to calculate is 4 to what power equals 256. So this is where your power sheet can come in handy. So hopefully you still have your power sheet. Let's take a look here. 4 to what power gives us 256? That would be 4. So we could say log base 4 of 256 is equal to 4. So in this first example, 3 to what power is 243? Look on our sheet. 3 to what power is 243? It's 5. So this whole thing just equals 5. It's not x equals 5. It's just 5. We simplified it. 2 to what power is going to give us 2? That would be an exponent of 1. 5 to what power gives us 1? Well, everything to the 0 power is equal to 1. 4 to what power gives us negative 2? There's none. It's not possible because you can't raise a positive number to an exponent and get a negative number. So if we have a log of a negative in the parentheses, we can't do that. And then finally, log of 1/3 of 81. So this is saying 1/3 to some power equals 81. Now, we know from graphing exponentials that when you raise a fraction to a negative exponent, that's when it changes to a fraction. So we know we have a negative, and then 3 to what power is 81? That's 3 to the 4th. So log base 1/3 of 81 is negative 4. So now that we understand where logs come from and what they mean a little bit better, let's graph them. So, graphing logarithmic functions. Logarithmic functions and exponentials are inverses of each other. So to graph them, we're going to switch the x values and the y values. So a is going to be out in front, b is our subscript, h is in the parentheses, k is on the end. So if we wanted to graph log base 3 of x minus 2 plus 1, a is 1 because there's nothing out in front, our base is 3, h is 2, and k is 1. So if we were doing an exponential function with a base of 3, our x's would be -2, -1, 0, 1, and 2, and our y's would be 1/9, 1/3, 1, 3, and 9. Well, since we're doing a log function, our columns switch. Our x's become 1/9, 1/3, 1, 3, and 9, and our y's are -2, -1, 0, 1, and 2. With our exponential functions, the domain was always -infinity to infinity, but since we switched to the x's and y's, that means this time the range is always -infinity to infinity. Similarly, our asymptote for exponential functions were always horizontal. Since it's the inverse, we're going to have verticals. Remember, verticals are x equals equations. And which of these letters is related to x? That would be our h value. So our asymptote is going to be at x equals 2. And that tells us our domain is going to go from 2 to infinity. So let's graph our h and our k as invisible lines. So we're going to use dotted lines. So h is 2, k is 1. And then we're going to graph this chart the best we can from our HK point. So we're going to go over 1/9 down 2, over 1/3 down 1, over 1 up 0, over 3 up 1, and over 9 up 2 is not going to fit, so we'll just leave it like that. Remember, you can cross this because this is not the asymptote this time. On your vertical asymptote, just be as close as possible and try not to touch it. So let's look at another example. Log base 1/2 of x plus 3 minus 2. Again, our a is 1. This time our base is 1/2. h would be negative 3, and k would be negative 2. We know our range is always going to be negative infinity to infinity, and our asymptote is going to be x equals negative 3. So our domain is negative 3 to infinity. Let's draw in our h and k boundaries. And let's think about what our chart would be. We know our y values are now negative 2, negative 1, 0, 1, and 2. 1/2 to the negative 2 power is 4. 1/2 to the negative 1 is 2. To the 0 is 1. 1/2 and 1/4. So from our hk point, over 4, down 2, over 2, down 1, over 1, 0, over 1/2, up 1, over 1/4, up 2, and then connect your dots. Now let's look at one where our a value isn't just 1. Here we have an a value of 2, a base of 2, an h of negative 5, and a k of 3. We know our range is always going to be negative infinity to infinity. H is negative 5, so our asymptote is at x equals negative 5, and our domain is negative 5 to infinity. So let's make our chart. Our y values would be negative 2, negative 1, 0, 1, and 2. 2 to the negative 2 is 1/4. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. Now remember, we need to multiply all our y values by our a value. So we're going to go, let's graph our h and k. From here, over 1/4, down 4, over 1/2, down 2, over 1, 0, over 2, up 4, over 2, up 2, and over 4, up 4. And then connect our dots to make our curve. That's all for today. See you in class.